and this is at the top of page 402, is the last formula that's up on the wall over there, the last formula for logarithms on your formula sheet, and it's called the change of base theorem. And the change of base theorem for a logarithm says, and I've color-coded it here so you can really see what's happened, is that if you have any logarithm with any base and any answer, you can change the base to anything you want. So one thing I want you to notice is that orange A that's on the right-hand side of that formula, there is no A on the left-hand side of the formula. This allows you to choose anything you want for A. In the example that we just did, right, we just had to graph to solve this, right? Or if you had the calculator that lets you do that button, you have to find it. But even on the graphing calculators that let you have that button, they're not necessarily easy to find. You might be on a test and I'm like, I see my log button, but I don't see that other button. I can't remember where to find it. Okay? What it allows you to do is it allows you to change to any base we want here of 6 divided by log, again, any base we want of 2. And what's a great base to use? Base 10, because that's your log button. Or base E, because that's your natural log button. So I'm going to show you that, right, some calculators let you write log base 2 of 6 and get that answer of 2.584. But if I do log of 6 divided by log of 2, I get exactly the same answer. Or if I do natural log of 6 divided by natural log of 2, I get the exact same answer. So this change of base theorem is really handy if you want a quicker way to type a value into your calculator. Or if you have a calculator, like a regular scientific calculator, that doesn't have the different bases available. So I've got another example here. I'm like, oh, if I wanted to log 3 of 7, I could change it to log 7 over log 3. I could change it to log base E of 7 over log base E of 3, which is the same as the natural log of 7 divided by the natural log of 3. So I have one more question I want you to try. Sometimes you will be asked to combine as a single logarithm, and now you could have the right-hand side of the change of base theorem up here in a question. And we have to be careful with the change of base theorem. Has a log divided by a log, and then you have your quotient rule that has dividing inside the log. So they're easy to get mixed up because they're very similar. Both involve dividing. One has dividing in the log, and the other one is a log divided by a log. So what we could do with this question is we could take that log divided by a log and say, this is my value of b, this is my value of x. I can change it to log base 3 of 7. And then since I'm adding and both of these have the same base, that's a log law for multiply. All right, so if we go to example 1, example 1 just wants us to use our calculator, but we're going to use the change of base theorem to type it in even faster. Log 5 of 50 will be log 50 divided by log 5. So go to my calculator. And I get 2.431. It says write the related exponential equation? Well, if we let x equal this, that would mean the base is 5, x is the exponent, is equal to 50. And we now know that if the exponent was 2.431, 5 to 2.431 would be very close to 50. We rounded, so it wouldn't be exactly, but it would be very, very close. Same thing with the second question. This will be log of 6 divided by log of 8. We type that into our calculator. And we get 0.862. And if we let x equal this, the base is 8, the exponent is x. This means that 8 to the power of 0.862 will equal 6. Okay, you can circle questions 3, 4, and 5.